do tonight here?
Solving trig equations.
Okay.
Okay, so the first problem is I have to solve for each equation for 0 less than theta less than 360. And so
That's the domain. In other words, they're talking about all thetas in the unit circle.
yeah.
360?
Yeah.
Go ahead.
And the problem is -3 plus cosine theta equals -6 plus root 3 over 2.
Like that?
No, -6 plus root 3 over 2.
Hold it. Okay. What's our first goal?
Well, I think -6 plus root 3, the whole thing is over 2.
Yeah, I was just going to say. -6 root 3 over 2, like that?
No, -6 plus root 3, and then the whole thing is divided by 2.
Like that?
Yeah.
All right. So what's the first thing we can do? Or what's the general idea going to be? The general idea is going to be to solve for cosine of theta, right?
Yeah.
And then solve for theta, but in that order. So how do we solve for cosine of theta?
You could multiply, or you could add 3.
Now what?
You can multiply by 2.
Yeah, okay. So what's the next line?
2 cosine theta.
Oh, hold on. You're going to multiply, everything by 2. Okay. All right. Go ahead.
Equals 6 minus 6 plus root 3.
Okay. What now? What's the next line? Give me that line right there. What's 6 minus 6?
0.
Now what's left to do?
Root 3 over 2.
Okay. Now we need to figure out where does that occur. First of all, how many answers are we going to have?
2 answers.
Okay. What angle is the cosine of that angle equal to root 3 over 2? In other words, what's the inverse cosine of root 3 over 2? Always go back to those triangles if you have to.
Okay.
Opposite the 30 is always 1. Opposite 60 is root 3, and the hypotenuse is 2. So which angle is the cosine of that angle equal to root 3 over 2?
30.
Okay. Now, with that information, we can figure out the second answer. First of all, what quadrant is the second answer going to be in?
fourth.
Okay. What's the angle? Just take 360 minus this first degree angle.
Okay, so negative 330.
No. Take 360 minus this first quadrant angle. What do you get?
330.
That is the fourth quadrant angle. Okay. Now, if you were to yeah, no, this is not a good example to mention what I was going to say. So there's your two answers.
Okay.
And yeah, the only real tricky part of this was combining that right there. That's an odd thing to have to do, and the way you did it is just fine. You could also split that up into two fractions. That's 3. That's root 3 over 2. And then the 3's would have canceled, and you'd have been left with root 3 over 2. Either method is about as good as
Okay.
the other one. Okay, what do you got next?
This one is 6 sine theta equals negative 4 root 3.
Like that?
Yeah.
Okay. Same domain?
Yeah.
Okay. First step?
Divide by 6.
So read me the next line, always. When I say first step, just read me the next line.
Okay, so sine of theta equals negative 4 root 3 divided by 6.
Now simplify that.
So sine of theta equals negative 2 root 3 over 3.
Sure we got this problem right?
Yeah.
Are you supposed to be able to use your calculator? Really?
Yeah.
Let me think about this for a moment. So what they're saying is the opposite side is 2 root 3, and the hypotenuse is 3. Let's see, what would that make this bottom side? This bottom side would be 9 minus, there's the problem right there. Is that number bigger or smaller than 1?
Bigger than 1.
Is that possible?
Oh, no.
Not with sine or cosine. It can never be bigger than 1. It can never be smaller than minus 1. So the reason this question in there is because there's no solution to this.
Okay.
That's what that means. Whenever you find a sine of theta or a cosine of theta outside its domain, then it's no solution. And when I tried to draw the triangle, I immediately realized that that is a bigger number than that. And yet so I can't have a triangle with the hypotenuse not being the biggest side.
Yeah.
All right. That's good. They're a little trickier than normal here. What else we got?
Okay, the next one is root 2 over 4 equals negative 1/2 times sine of theta.
First step.
So you would multiply by 2 over 1. So root 2 over 2 equals negative sine of theta.
Well, let's just multiply everything by minus 2.
Okay.
So minus 2 root 2 over 4 equals sine of theta. Now that becomes a 1 over 2, or root 2 over 2 equals sine of theta. That does happen to be one of our common angles. Which one is that? Which one is the first quadrant angle? Ignore the negative sign for a moment. Always, actually. Okay. Always see if you can remember what that is. And boy, if you want to memorize anything to be good at trig, you got to know your first quadrant angles. You just do. Okay. Sine and cosine. Not so much for the other 3 or 4, but for sine and cosine. Sine is equal, that's the same as 1 over root 2. In other words, normally the way I would draw my triangle, and different schools do this differently, is I label it 1, 1, root 2 for a 45-degree angle, okay? So I get the sine of theta equals 1 over root 2, and I leave it at that. But if you rationalize that, you get root 2 over 2. So when you see that root 2 over 2, and this is the triangle you're used to, be able to take that leap and unrationalize it.
Yeah.
Okay? So we're dealing with a 45-degree angle.
Yeah.
Which 2 quadrants is sine equal to negative root 2 over 2?
3 and 4.
Okay, so what's the third quadrant angle?
225 degrees.
And what is the fourth quadrant angle?
315 degrees.
Okay. There you go. Which one do they teach in your school system? The ones, or do they label it like this? In other words, a lot of them will label it, hold on, root 2 there, root 2 there, and then just 2 here. So,
yeah, that's
so that comes out kind of rationalized. And that's the same triangle. It's just a multiple of the first one, a multiple of root 2.
Yeah.
All right. So what else we got? So far, there's been one little tricky thing about every single problem.
Okay, the next problem is in parentheses, cotangent x minus 1 parentheses times root 3 cotangent x plus 1 equals 0.
Plus 1?
Yeah. And it's not negative root 3, it's just positive.
Everything else is correct?
Yep.
Okay. What should I do with this?
You could solve for cotangent.
Aha. In other words, the thing not to do with this is to multiply these 2 things back together again. Right? Okay. In other words, they were kind enough to not make us factor it in the first place. They could have just given us the difference of squares or something like that. They could have given us a quadratic. They didn't. So, how do we solve? Tell me how.
You could do cotangent x equals x minus 1 equals 0.
Is that written correctly? The x minus 1 is not in parentheses, correct?
It is.
So it's this?
No. You wrote it right.
Okay, so if the cotangent of x minus 1 equals 0, then cotangent of x equals 1. Where does that occur? What's the tangent of x going to be if the cotangent of x equals 1? What's the relationship between cotangent and tangent?
They're inverses.
Reciprocals.
Reciprocals.
Okay, so if the cotangent of x equals 1, what's the tangent of x equal?
0.
Also 1.
1, yeah.
Reciprocal of 1 is 1.
Okay.
Okay, now think of your two little triangles, and where is the tangent of x equal to 1? This is perhaps the most important skill in Trig, is handling those two triangles and those common angles. Okay? By that, I mean you should be able to draw those two triangles right now, even though I don't have them up there. And then start searching for an angle where the tangent equal to 1. It's in one of those two triangles, I guarantee you. And it's one that you should memorize. Just like you should know the sine of 30 degrees is 1/2. And the cosine of 30 degrees is √3/2. Tangent of this angle equals 1. This is the third most important one to know. It's 45 degrees.
Okay.
Okay. Notice that in your 45, it's 1, 1√2. So the tangent of 45 is 1/1. What other quadrant is it equal to 40, or is the tangent positive?
The third.
So what's that angle?
225.
Okay. So there's two answers. Now let's have a look at this. For that, we have to solve this equation. I'm going to go ahead and put the 1 on the other side. Now I'm going to divide by √3. Now, if I draw the two triangles, I would much rather you pay attention to what we're writing here rather than trying to look up the answer. Okay?
Okay.
Because looking up the answer just means you're trying to memorize it. If you want to memorize something, memorize these two triangles and you'll always be able to know that answer. Okay? So, which angle is the cotangent equal to 1/√3?
Cosine of 30 is 1/3.
Which angle? You got two choices here. It's either 30, 60, or 45.
Oh, 30, 60.
Okay, it's that triangle, but which angle in that triangle is the cotangent equal to 1/√3? Let me ask you this. Which angle is the tangent equal to 1 over root 3?
30 degree.
Okay. So what would the cotangent of 60 degrees be? Or excuse me, let me reverse that. So if what is the tangent equal to?
Of 30 degrees?
Yeah.
Root 3 or 1 over root 3.
Let's not rationalize it because we've got it in unrationalized format and it'll just confuse us to put it in rationalized format. Okay, so tangent is TOA, okay? So instead of opposite over adjacent, we want adjacent over opposite. So when we're talking cotangent, which angle are we talking about?
The 60 degree.
Yeah, we want adjacent. There's only one adjacent. Well, there's two adjacents, but they never mean the hypotenuse. It's the short side adjacent divided by the opposite. In other words, cotangent would be CTAO. Just the inverse, not the inverse, excuse me, the reciprocal of what some of us would call the primary trig function. So the angle we solve for is what?
60 degree.
All right. And what is the other angle in that unit circle where the cotangent is equal to 1 over root 3? And first of all, that's the equivalent first quadrant, but which two quadrants are we in? We've got a negative ratio.
2 and 4.
Correct. So what's the second one? What's the second quadrant equivalent of 60 degrees? Here, I'm going to write 60 degrees down here like that. And now just figure out what's the second and what's the fourth.
120 degrees. And
in the second, it's always 180 minus the angle. In the fourth, it's always 360 minus the angle.
Okay, and 330.
No, it's 360 minus this 60 degree angle.
300.
It's always those two things. If you'll remember our unit circle, we have those written right there. This one is x minus 180, and this one's 360 minus x. So whenever you have a first quadrant angle and you're trying to convert it to a second, third, or fourth, just use those three formulas. You do got to memorize those. That's what you should memorize. And that way, the only thing you really have to memorize are these two triangles right there. Because that allows you to figure out all of the first quadrant angles, and these three formulas allow you to figure out all of the second, third, and fourth quadrant angles.
Okay.
Okay? So we have four answers here. And all of them are valid. It can be 45 degrees, 225, 120, or 300.
Okay.
Every one of them makes that original equation true.
Okay.
Now, it's possible they could have made this a little bit harder by starting with this. Okay, something like that. Only it would have been not square root of 3, it would have been 3. In other words, they would have started it as a quadratic, and in order to solve it, we would have had to have factored it into these two factors. So that's why I'm saying they gave us a little bit of a break on that. Didn't make it. They didn't make us do it the hardest possible method. All right, what else do we got?
The next one is cosecant squared x minus cosecant x minus 2 equals 0.
Okay, I'm sorry, cosecant squared x, start from there.
Minus cosecant x minus 2 equals 0.
Okay. This is what I call a quadratic in disguise. Okay? If I gave you this down here, this is called a quadratic in x. It's always that middle term. Okay? What would this quadratic be called?
Quadratic of cosecant.
A quadratic in cosecant x.
Okay.
Not in cosecant, but in cosecant x. Okay? So we're going to solve this exactly the same way we would solve this polynomial. Over here, I'm factoring it into that times that. And I got my solutions. X equal 2, x equal minus 1. So we're going to do that same process, only we're going to factor it into cosecants.
Mm-hmm.
Help me.
Okay. Cosecant x minus cosecant.
Hold on. Let's do our factoring. Let's split up the cosecant squared x's first. So far I haven't written anything over here. I need to write over here also cosecant x.
Yeah.
In other words, the first thing that's going to happen is these two things are going to get multiplied together and they have to equal cosecant squared of x.
Mm-hmm.
All right. So what's the rest of it?
What
are both signs?
Minus and plus.
Factors of 2 that subtract to the number 1, because that's the coefficient in front of cosecant x, is the number 1.
So minus 1.
It's going to have to be, you put the bigger factor with the sign of the middle term, so the 2's got to go there, the 1's got to go there.
Okay.
Okay? Now, let's solve the fun one first. Cosecant x equals 1. Where does that occur?
That occurs,
think about what we did with cotangent. What is the reciprocal function of cosecant?
1.
No, what's the reciprocal function?
Oh, cosine.
No, they don't ever begin with the same letters.
Oh, sine.
So if the cosecant of x is equal to 1, then the sine of x is equal to 1 also. Okay?
Okay.
Here's how you graph the cosecant curve. You start with the sine curve, and then you put the cosecant curve on the tops and the bottoms. And then you erase the sine curve. And why do they touch right there? Because that's where the sine is equal to 1, which means by definition the cosecant also has to equal 1.
Okay.
Okay. Now I'm going to erase the sine curve. What if this thing would have said cosecant x equals 1/2? instead of 1? We'll get back to 1 here in a second, but what if it would have said 1/2? What would that have meant? What does cosecant's range or domain? Look at my graph. It always has to be greater than 1 or less than -1. In other words, it has the opposite domain as sine and cosine.
Okay.
So if you got an answer like that, that's impossible. That one would get crossed off. Just like we cross it off when sine comes out to be a number greater than 1.
Okay.
Now, in this case, where is x to be equal? So the sine of x is equal to 1. Where does that occur? In other words, what is that on the x-axis? That's 360. It's 180. It's 270. Where's this one?
On 180.
No, that's on there. There's 4 quarter points that are always key on any sine or cosine curve. And the quarter points are as you take the distance out to the end of the period, in this case 360, and you quarter it
0
out.
degrees. Okay, 0 degrees.
No, 90. In other words, we're looking for the point where that is true, where the sine of that angle is equal to 1. That's at 90 degrees. And that is the only place inside where it's equal to 1. Notice no other place inside the unit circle is it equal to 1.
Okay.
Okay? So that satisfies the easy one, because there was only one answer. Now let's solve the second one. We get 90 degrees as one of our answers. Okay, now we're going to solve this. Now, you can think in terms of those two triangles and actually think in terms of what the cosecant's doing, but I wouldn't do that. I would say to myself, if the cosecant's equal to 2, what's the sine equal to?
1/2.
That you should have memorized. Where does that occur?
30 degrees.
Yeah, there you go. See, it's much easier to do that conversion to sine, and then you know the answer instantly, rather than having to go to the triangles and figure out where is the hypotenuse over the opposite equal to 2. And what's the second angle?
150.
Yeah, I was just going to say, what's the formula for the second angle? 180 minus theta.
Yep.
That's how you got 150. Another thing, I tell all my geometry students, the best skill you can have in geometry is being able to subtract a number from 180. Because that's what you have to do all the time. Well, guess what? It doesn't stop at geometry. It's also true in trig. You're always subtracting from 180, or in the fourth quadrant from 360. Okay, so we got 3 answers, 90 degrees, 30 degrees, and 150. All right, what else?
Okay, so this problem is cosine theta minus tan theta times cosine theta equals 0.
The whole thing times something?
No, it's just cosine theta minus tan theta times cosine theta.
Okay? What should we do?
Divide by cosine theta.
What's that?
Divide by cosine theta.
Factor out a cosine theta, yeah. In other words, the very first thing you really want to think of when you're solving trig equations is how would I solve an algebraic equation? If I had x minus xy equals 0, I would factor out the x. Well, we're going to factor out cosine theta. What's that leave?
Minus tan theta.
No. You got to factor out your greatest common factor from every term. So when I factor it from the cosine theta, I divide it. What's left when you divide cosine theta by cosine theta?
Minus tan theta over cosine theta.
No. This right here. Redistribute those. Do you get what you started with?
Yeah.
Okay. So that's what you want to do on all of these. Factor them or treat them like a quadratic like the previous problem. But treat them out just like you would algebra. Okay, now solve. Tell me how to solve.
Okay, so you would just do 1 minus tan theta equals 0.
I'm going to do it like this. Go ahead and solve that.
So negative tan theta equals negative 1.
You know, I would rather see you not invoke negative signs if you don't have to.
Okay, yeah, so tan of theta just equals 1.
Okay. Now, where does that occur? Where is the tan of theta equal to 1? That's one of those you need to memorize. Think of your triangles. You should just draw those triangles and have them in front of you, fully dimensioned. I would rather you do it from memory because that's what you have to do on a test. But if you could write anything on a test, that should be the first thing you would do. You've got to get these first quadrant common ones memorized. That's the
45 degrees.
So where does it occur?
45 degrees.
And where else? Which quadrant?
Third quadrant.
Okay. In the third quadrant, the math becomes a little trickier, but what's the equivalent of a 45 degree? You know it in your head.
225?
Yeah. What you really did was you added 45 degrees to 180, right?
Yeah.
And that's what you always want to do in the third quadrant.
Okay.
Okay, now let's go over and solve the rest of it. That's just part of it. In other words, that's that part. Now we got to solve that part.
Okay. So cosine theta equals 0.
Where does that occur?
At 0 degrees and 180 degrees.
No. Cosine does not start out at 0. It starts out at
90 degrees and 270 degrees.
Okay. And it does occur in two different places. So there's 4 answers. 1, 2, 3, 4. All right. That's the secret, is always just be thinking algebra.
Okay. Okay, and this one is 2 sine square theta minus 3 sine theta minus 2 equals 0.
Okay, what am I going to do here?
Factor.
Okay. First step.
So you're gonna do sine of, so
how are you going to break this up? It's always the first step. Break that up. Come up with two things that multiply together to that.
sine theta times 2 sine theta.
That's it. Second step.
And then minus 3 sine theta.
Second step.
Break down the second part.
Second step is to figure out both sides, always.
Okay.
People forgetting that step, that makes factoring difficult for them. You just always just do step 1, step 2, step 3. You'll end up with the answer. Now, I know they're opposite, right?
Yeah.
But this is one of those cases where plus minus does not equal minus plus. Because the coefficients of the first term are different. If those coefficients are the same, then I can live with just a plus minus. But in this case, I also have to consider minus plus when I'm factoring.
Okay.
Now, I also have to throw out all those rules, because all I know is my numbers are 2 and 1. Okay, so which one is going to work? Tell me what to do. I don't have that many choices. The numbers have to be 2 and 1, but I can put them on the left, the right, the bottom left, the bottom right. Tell me where to start.
So you put 2 in the first one.
Which forces a 1 there. Now let's see if that gives us the correct answer, does it? In other words, the next step is to see if that gives us the middle term.
Yeah.
No, it doesn't. Do the double smiley face. That gives us 4 sine theta. And that gives us minus 1 sine theta.
Okay.
Which totals to 3 sine theta. That is not the middle term. But it does tell us what the answer is, because we got the right number, we just got the wrong plus or minus sign with it. So what do I have to do? Where should my 2 and 1 go?
You just switch them?
No, you don't switch them left-right. You switch them vertically.
Okay.
In other words, the 2 goes there, and the 1 goes there, and that, you'll notice, will give you the correct middle term. In other words, it'll make this minus 4 sine theta, this plus, and that whole thing will be minus. And that's always the case. In other words, and you should use that information in the other way also, in the sense that had I not gotten the right number, there's no point in moving the 2 down and the 1 down. That's not going to be correct either. So in that case, I would switch them horizontally as my next step.
Okay.
So getting the right number or not getting the right number is important information when you're doing these. In other words, this is a trial and error operation or process. And so use that information to make it the most efficient. Now, let's start with the easy one. Solve that.
Okay, so sine of theta equals 2.
Well, I'm setting that whole thing to 0, which gives me sine of theta equals 2. Possible or not possible?
Not possible.
Then that's not a solution. Remember, algebra says when you multiply two things together, one of them has to be 0. Nobody said that both of them have to be 0. And this cannot ever be 0. That's impossible for the theta to even be 2. So now let's work with the other one. I'm going to move the 1 over. Next line.
Sine of theta equals negative 1/2.
And where does that occur?
30 degrees.
Okay, I'm going to write 30 down here, because that's not actually one of the answers. But that's what both answers are going to be based on. And I would advise you doing something similar. Just use some sort of notation where you know that that's not one of the answers, but that's how we're going to get to the answers.
Okay.
Okay, so where is sine negative?
Negative 150.
No, first of all of our answers have to be between 0 and 360. So negative answers don't work. Negative angles. They might be correct, but they don't fall in our domain.
Okay.
So we have to have two angles that are in the unit circle, between 0 and 360 degrees. First of all, which quadrants? That's the thing you have to ask yourself first. Which
3 and 4.
Okay, 3 and 4. So I'm going to write a 3 there and a 4 there. What is the third quadrant angle that is the equivalent of 30 degrees?
210.
Yeah, and when I say the equivalent, I don't really mean they're equal, but they have the same trig function value, absolute value, sorry. And the fourth one?
330 degrees.
Yeah, just always subtracting from 360 or adding to 180 or subtracting from 180. That's all you're doing. And so we have two answers, that one, that one. Okay. Still have a little trick in every one. The trick in that one was that the sine cannot be equal to 2.
Okay, this one is 9 tan squared x minus 3 equals 0.
Next line.
9 tan squared x equals 3.
Next line.
Tan squared x equals 1/3.
Next line.
Tan of x equals plus or minus root 3.
Plus or minus what?
Root 1/3.
Okay, or just 1 over root 3.
Yeah.
In other words, that's my preferable way of writing it. This certainly relates to the triangles better, to leave it not rationalized. Happens to be the same as root 3 over 3. So had they set up the equation where this would have come out root 3 over 3, just know that that's the same as 1 over root 3.
Yeah.
Okay, but plus or minus is important because that's going to give you 2 more answers, and we already should have 4. So all we have to do is figure out, first of all, what angle are they talking about? What first quadrant angle, which I'm going to put
30 degrees.
And now give me, it's clearly going to be all 4 quadrants, right? There's one.
And then 150 degrees. And then 210 degrees. And then 330 degrees.
There you go. Now you're getting fast at it. All right, that's good. What else?
Okay, this one is 4 sine squared theta plus 4 equals 5.
Just occurred to me on that previous problem. There were 2 ways to solve that. One is you could have taken the square root of both sides right off the start instead of dividing by 9.
Uh-huh.
And notice if you do it that way, you do get root 3 over 3.
Mm-hmm.
You don't get 1 over root 3. So doing it that way actually makes it harder, because you have to recognize that root 3 over 3 is the same as 1 over root 3.
Yeah.
All right. What here?
Okay, so you subtract 4.
Okay.
So 4 sine squared theta equals 1.
Okay.
And then you divide by 4, so sine squared theta equals 1/4.
Okay.
And then you square it, so sine of theta equals plus or minus 1 and divided by root 4.
Which is what number?
Oh yeah, 1/2.
Uh-huh. Remember, when you take square roots of fractions, the answer gets bigger.
Okay.
As opposed to taking square roots of numbers greater than 1, where the answer gets smaller.
Mm-hmm.
And that confuses a lot of people. They're not used to taking the square root of something and having it get bigger. But it happens,
Okay.
as long as you're talking about a number less than 1.
Mm-hmm.
Okay, again, because we have the plus or minus, theta is what degree?
30.
All 4 quadrants.
30 degrees, 150, 210, and 330.
Practice makes perfect. Really does. I've seen your skill in naming these angles grow by leaps and bounds in just 30 minutes here.
Mm-hmm.
Okay, what else?
This one is cosine squared theta equals cosine theta plus 1 minus cosine squared theta.
Plus 1?
Yeah.
Minus cos, like this?
Minus cosine squared theta. Yeah.
Just like that?
Mm-hmm.
Okay. What are we going to do?
You can add cosine squared theta to the other side.
Which side? Which side am I going to
The
put stuff on?
left side.
Okay. So we'll start by putting that over there.
Mm-hmm.
Takes care of that and that.
Then you can subtract cosine theta to the left side and 1.
Now what are we going to do?
And then you have to factor it. So it would be, the first side would be 2 cosine theta. And then the other side would just be cosine theta. And then it'd be plus on the left side and minus on the right side.
Or minus on the left and plus on the right.
Mm-hmm.
Okay. Give me a starting spot. At this point, it's all trial and error.
Mm-hmm. So you could do plus
Doesn't
cosine.
really matter where you start. I don't try to figure it out in my head before starting. I just start. Okay? Because that's going to give us so much information. If this isn't the right answer, we're going to basically know what is the right answer.
Mm-hmm.
What does this produce in the middle?
Cosine theta.
On the outside?
And then 2 cosine theta.
No. Outside is a negative 1.
Oh, negative 2 cosine theta.
Now combine them.
And you get negative cosine theta.
Bingo. We got it right on the first try. Sometimes that happens.
Mm-hmm.
But notice that had it been wrong, we'd have known what the correct answer had to be. There was only really one other combination.
Yeah.
in this particular case, since 1 is 1. Okay, so, oops, hold on. Next step.
You would solve for them.
Go ahead.
So it would be, the left one would be cosine theta equals -1/2. And so theta is 60 degrees.
Where is that occur? In other words, that's the first quadrant angle, but that's actually
120 degrees. 120 degrees and 240 degrees.
Okay.
And the other side is cosine theta equals 1. So that would be 0 degrees and 180 degrees.
No, just 0, believe it or not.
Oh, yeah.
Whenever 1 is the answer, there's only one spot, whether it's sine theta or cosine theta. If they're equal to 1 or -1, there's only one place in the unit circle where that occurs. And that is the only argument that is like that. Anything other than 1, and there's going to be 2 spots.
Okay.
Okay. So our answers are that, that, and that, but not 60. That's just how we use that as a reference. That's the reference angle.
Okay.
60. All right, let's see. I think I took you beyond your time. Good. You made a lot of progress in that session. Look at your test tomorrow.
Thank you.
You're welcome. Have a good one, Ved.
Yeah.
Bye-bye.